So let's solve this to some problem of LeetCode. So the question is, given an array of integers and return indexes of two numbers such that they add up to the target. So what does this mean? Let's see it with an example. So we have an array 2, 7, 11, 15, right? Now, if I'll add 2 plus 7, that gives 9. So the output would be 0 and 1. So 0 index, if we'll do 0 index with, um, if we'll do a sum of 0 index along with first index, then the total should be the target number, that is 9, right? So this is what the expectation is, right? So now let's see how we can achieve. So let's first do the brute force way. How we can solve it is pretty simple. Two loops will take. So let's say for let I equals to 0, I is less than nums dot length I plus plus. Here, so this is for 2, 7, 11 and 15. First we'll iterate through 2. So once 2 is we have started with 2, then we'll need another number to add it, right? So let's write for the another loop for this that purpose, right? Let j equals to, so j will start from where? So j will start from I plus 1. That is mean j will start from here, right? So that will be I plus 1. Then j is less than nums dot length j plus plus. Okay. Now, if we will add this one with this one, that should be comparing with target, right? So that means if nums of I plus nums of j equals to let's match the type also. Okay, target, then we will return to values I comma j. Okay, so let's see the test cases. Yes, it took 85 millisecond. Case 1, 2, 3. Fine. Let's run more test cases. Yes, it is fine. You can see it. Okay, so this is fine, right? So run time complexity is not so good, but yeah, bits 49%. I mean, it's fair, and space complexity is good, 50%. Okay, so let's now see, but the thing is here the time complexity is going to come big O of n square. The reason is we are using two loops. So the inner loop will run n times, and for each element of the outer loop, the inner loop will run for n time. That means it would be running something like this. So let's say your outer loop is I equals to 1, I equals to 0. The inner loop will run 0 to max length, right? Max n times, let's say. Then I equals to 0, I equals to 1, it would again run 0 to n times. So like that it would keep on running. So that means for 0 to n time of I, the inner loop would be running each time n. So that makes it n square, right? So this is the time complexity. Now can we try this same thing with big O of n? So let's see.
So now let's see how we can improve the time complexity here. So here we have now big O of n square, which is not great, right? So let's see how we can do it with big O of n. So to do that, we need to do a trick. Let's understand that first, then we'll write the code. So here we have a simple array. Okay, this is having 2, 7, 11 and 15. and we are trying to find 9. So 9 we'll find by adding any two of its values, right? Two of its values from this array, right? So here if you'll see, this is giving us 9. Now the thing is, how would you find it easily, right? So let's say we have a simple object. So here we have a simple empty object, and then what we'll do is we'll run a simple loop, for loop or while, whichever you want. You run a loop and we'll iterate through it. Okay, so for the first element, when I equals to 0, the element would be 2. Now here we will see first whether this 2 is there inside this object. No, as it is empty, it would not be there. Then in that case, what we'll do, it is not there, so what we'll calculate the complement of it. So the target is 9, so 9 minus 2 is 7. So 7 is the complement which we are looking for. So 7 and current 2 will, by adding these two, it will become 9, right? So we are looking for 7, right? So now we will find, okay, this is the complement. Okay, this is the complement value. So once we'll find this, we'll add this complement value to this object. So now this object will become 7 colon and the position where we calculated the complement. So the position was 0. So this will be 0. Okay. Now we are clear that we have 7. We needed 7 when we were in I equals to 0. Okay. Now the loop will go for I equals to 1. Here it will see 7. Okay. 7 is the value. As usual, we'll search first inside the object. So currently this object is this one. So here we'll search, is 7 there in the object? Yes, it is there. If 7 is there in the object, we will not find any complement again. So what we will do is, we will just find out which position we had stored this 7. 0th position. That means 0 is the position where we were needing 7, right? Or we had calculated complement 7. And what is your current position? That is 1. So here it would be 1. So this should be your output, 0 and 1. You can see here 0 and 1, which is becoming 9. Okay, now we will take a object. Let obj equals to initially empty. Now we will write a for loop for let I equals to 0, I is less than nums dot length, then I plus plus. Here inside this we'll put a if condition. If your object, okay, so the obj of nums of I, so do we have the current value in the obj? So we found it. It is not undefined, that means we found the value. Okay, it is there. In that case we will return the array. So what would be the array? Your obj of nums of I, your position where you had entered it, and current, right? Else what we'll do, obj of target minus complement, right? That we are going to store. Nums of I equals to your current position, right? And if we don't find, let's return empty. Okay, so let's see. Yeah, accepted. Let's run for more. Okay, so we bit around 80%. Okay, good. This is better, right? So if you'll see, we are using 80 to 43 MB, and this is quite good, right? Better than 80%. Yeah, this is a better option than brute force, and we are having a time complexity of big O of n here. Okay.